The very first decision I'm going to have to make before taking this set into production is whether to use mipmaps or not. And essentially, it depends on how much memory you have available on your render machines and how much memory your textures are likely to take up. Now, if you're working with a very limited amount of RAM on your render machines, for example, if you've only got 8 or 12 gigabytes available, then you're almost certainly going to need to use mipmapping for any textures that are going to be close to the camera in any shots that are rendered in HD. However, if you've got more memory available to you, then it becomes more of a balancing act, because if you are going to use mipmapping, there's always going to be a processing overhead and it's going to slow your renders down. And that's because mipmaps inherently have more processing overhead than regular image maps, because the render engine has to decide which level of the map to extract, and then it has to spend some time extracting and decompressing the right level of the map for the frame. So the upshot of this is that if you have enough memory, it's actually better to use high-res 8K textures on your assets rather than using mipmapping, but you should always allow yourself the option of using mipmaps, just in case you have some scenes where there are so many assets that need high-res textures that you can't fit them in memory even when you've got 32 gig of RAM available on your render machines. So in order to test this out for this shot, I've created two versions of this scene, one that uses mipmapping and one that just uses high-res PNG textures at 8K. So this is the version with mipmaps, and I'm going to do a test render to see how long the render takes and how much memory it uses. And here is the completed render, and you can see that at 1280 by 720, the render's taken 6 minutes and 43 seconds. And if I switch to my task manager, I can see that Modo was using 6.4 gigabytes of RAM during this render. So what I'm going to do now is I'm going to close this scene, and in fact I'm going to restart Modo completely in order just to reset the RAM, and then I'm going to open a different version of this scene, which instead of using mipmapping is using regular PNG files at 8K, and I'm going to do a render using this scene and compare it in terms of memory use and render time. And here is the completed render. And you can see that whereas the previous render took 6 minutes and 43 seconds, this render now taken 6 minutes and 28 seconds. So the render time difference isn't enormous, it's only in the order of 15 seconds or so in this particular case. But let's have a look at memory use. You can see that now I'm using 11.2 gigabytes of RAM, whereas in the previous render I was only using 6.4 gigabytes of RAM. So that's a substantial difference. And if I only had 8 or 12 gigabytes on my render farm, I really would have to be using mipmaps, especially as in this case, this is the empty set with no character, and the character is also going to come in with his own set of very big textures. But in this case, as I've got plenty of memory overhead here, you can see that even when I'm using the regular 8K image maps, I'm only using about 1/3 of my memory. So even with a character in the scene, I'm confident that I'm going to be able to fit the scene comfortably in the RAM available. And I really need to squeeze every ounce of performance out that I can, because I'm rendering at home on my own machines, and so every second is going to matter to me, especially once we add up hundreds and hundreds of frames. Now finally, if you're dealing with render systems with a limited amount of memory, there's another potential cause of slowdowns when you're using mipmapping. If I go to System Preferences and we go to Image I/O, if you've ticked the option to limit the tile memory, because obviously you need to fit your textures within a certain amount of RAM, just bear in mind that this could cause further slowdowns, because as EXR tiles are flushed out of memory, they may need to be reloaded later on during the render, and that's obviously going to cause extra processing. So at this stage I've got an animation that's ready to go into lighting, and the way that the animation is set up is that it's referencing in the rigged character, and it's also referencing an untextured version of the set. So I'll just quickly play my animation. My shot's 100 frames long, and you can see there's no lighting on it whatsoever at the moment. So what I'm going to do now is I'm going to import this shot as a reference into a new scene where I'm going to start doing my lighting. Now in order to do that without getting any glitches, I'm going to need to restart Modo. So I've set up a fresh scene, and what I'm ready to do now is to import the animation that we were just looking at. So I'm going to go to File, Import Reference, and import the animation, and I'm only going to import the meshes and the cameras. So I'm just going to pause the video while I do this because it might take a few seconds. So with my animation successfully imported, we can see that in the Shot1 Publish folder I've got the camera, the character, and the set. So I'm going to set my preview to go to the camera that I've just imported, and As it refreshes, you can see that we've got the character, we've got the animation, we've got some basic lighting coming from this direct light that's outside the window. So the next thing I need to do is to import my shading. So I'm going to go to File, Import Reference, and this time I'm going to find my published files. And I start by importing the shading for the workshop. So I'm going to select this file, and this time I'm only going to import the materials and shaders. Let me just pause the video while these come in because it will take a little while. And with the shading now imported, you can see there's a new group in the shader tree, Workshop Shading Published. But if I unpause Preview, you're going to see that the shading isn't applied yet. And if you've watched the referencing video, you'll probably know exactly why. Because as you probably remember, when you import shading from a reference file, it's automatically item masked to the group that's created when you import the reference. But this group, in this case, does not include any modeling. So the item masking is basically preventing all this shading from being applied to the models correctly. And so what I need to do in this case is to change the item masking on this group. So if I go to the texture layers, we can see that the item mask is pointing to this folder here, but I actually need it to point to this folder here. So I'm simply going to manually change the item masking by choosing the correct group for the shading to be applied to, because this is the group, if I expand it, that contains all the models. And if I now unpause Preview and we wait for a few seconds, we should see that as the scene updates, the shading will now be applied to the workshop. And I'll just pause Preview again, and you can see that it's all there. So we need to do the same thing for the character now. So once again, I'm going to go to File, Import Reference, and this time I'm going to choose my Android Shading Published file. And once again, I'm just going to bring in the materials and shaders. I'll just pause the video while these come in. And with the shading for the character imported, you can see that we've got another new group in the shader tree, Android Shading Publish. And once again, I'm going to need to change the item masking on this group. So once again, I'm going to manually replace the item mask, and this time I need to select the Android Rigging Publish folder in the item list, because that is what contains all the meshes for my character. So with that done, it's time to unpause Preview once again. Just wait a few seconds to see as the character updates whether the shading is now correctly applied. And you can see that yes indeed, we've now got shading on the set and on the character. So with all my assets in place, I can now start thinking about lighting this scene, and the first thing I'd like to do would be to change this directional light into a physical sun. So I'm going to tick physical sun, and I've already got some values that I entered in earlier. So I've set the time to 1800, and I've also set the clamp intensity to replace, and I've set the radiant extents to 50, which means that basically this value is controlling the strength of my sun. If I left it on none, it would just use the values which are baked into the sun, and if I left it on clamp, it would clamp it at 1. So by using the replace option, this gives me the maximum control over my sunlight. And finally, in order to control the orientation of my sunlight, I've set my north offset to 175 degrees. So with all that done, I'm going to unpause Preview and we can have a look at what the initial lighting looks like. So you can see I've got a nice sunlight coming through the window, and it's giving a good dramatic effect on this shot. Before going any further, I need to set up my render outputs. At the moment, all I've got in the scene is the default final color output that you get when you create a new scene in Modo. And so what I've done as part of my personal pipeline is I've set up a preset which has all of the render outputs that I need for this film. So I've opened my preset browser by hitting F6, and what I'm going to do now is I'm just going to double click on this preset, and you can see that it's created a new group in my shader tree called renderoutputs.lxp. So I'll just close my preset browser and I'll grab my new render outputs and just drag them to the top of the shader tree, and then I'll select my original render output and simply delete it from the scene because I'm not going to need it anymore. So let's have a look at this preset I've just loaded. So I'll just expand the render outputs LXP folder, and we can see inside there's several different folders with different types of outputs inside. So in the technical outputs folder, I've got the motion vectors and the depth. Inside the shading folder, I've got all the different passes that I'm going to use in Nuke to do my compositing and reconstruct the final beauty. So these passes are all added together in Nuke, and it's the transparent shading, subsurface shading, specular shading, reflection shading, luminous shading, the indirect diffuse shading, and the direct diffuse shading. And then below that, I've got a volumetric scattering output, which is basically going to allow me to control my volume lights separately from my shading. Very, very useful. It means that I can render my volumetrics with low quality and then just blur them in Nuke. I've also got a bloom output, which is essentially just a final color output with the bloom option ticked. And that means that if I want to use some native Modo bloom, I have that option because I can composite it into the image. Finally, I've got a regular final color output and an alpha output. And below that, I've got some illumination outputs. I've got shadow density outputs. I've got indirect illumination and direct illumination. Now, I'm not going to composite from these directly because it's not really very easy to do, but I can use them for masking purposes. And it can also be very useful to have illumination outputs rendered out separately in case you need to troubleshoot. So you can look at the illumination outputs just to see if there's noise in your GI, for instance. So I always render these out because I just find them invaluable. So I think now would be a good time to start doing some test rendering. So what I'm going to do is, first of all, I'm going to unpause preview just to see what state my shot is in. Just pause the video while preview updates. So with preview updated, I can see the first problem is that the scene is very dark, despite this very bright sunlight coming in the window. And the first problem I've got to tackle really is the environment, because I'm using the default environment, and this simply isn't bright enough to work alongside the physical sun. So I'm going to expand my environment and go to the environment material, and as the environment type, I'm going to select physically based daylight. And as my sunlight, I'm going to select my directional light. And once again, I'm going to unpause preview just to see what that gives us, but I'll pause the video while it refreshes. And with preview refreshed, you can see there's stronger reflections now on the wood of the floor and the table. Now, if I was to unclamp the sky brightness and unpause preview again, you can see these reflections get much, much stronger, but I find these really strong reflections from the unclamped sky a bit too strong. So I'm actually going to clamp it again for now. I could manage the strength of the lighting by using the white level in my render outputs, but I don't really want to be changing that right now. So I'm going to just clamp the sky for now. And the next thing I'm going to look at is the global illumination settings. So I'm going to switch to the render item. And the first thing I want to do is to reduce my pixel resolution by half because I want my test renders to be a bit quicker. So I'm going to hit divide by 2 right in the field there for the frame width. And if I hold down Control as I hit enter, you'll see that it makes a change proportionally. So it's changed my frame size to 640 by 360. Next, I'm going to go to the GI settings. And the first thing I'm going to do is just to increase my indirect bounces to 4 because I just want a bit more light bouncing around the room. And next, I'd like to add some volume to the light that's coming through the window. So I'm going to select the directional light and I'm going to activate volumetrics. I've set the height to 8 meters and the radius to 5 meters. And now I'm going to do a test render to see what it all looks like. And here is the first completed test render, and it's rendered in just 1 minute 23 seconds. So if I was to double the frame size back to what it was, it would take 4 times longer, so approximately 5 minutes to render this test, which isn't too bad. But at the moment I'm using irradiance caching, and I know that I can't really use that for an animation shot because it's likely to flicker. So what I'm going to do is to return to my scene and select my render item again, go to the GI settings, and I'm going to keep the irradiance caching, but I'm going to use it on the second bounce only. And also, I know that it's not going to be practical to use 4 bounces, so I'm going to reduce the number to 2, and I'm going to pause the video while I do another test. And so here is the render with irradiance caching on the second bounce only, and you can see that although the render time hasn't changed much, it's only gone up by about 6 seconds, it's much, much noisier. So I'm going to need to return to the scene and increase the number of Monte Carlo rays. So let's try 512 and do another test render. And here is the completed render. And you can see with 512 Monte Carlo rays, the render is a lot less noisy. However, my render time has more than doubled, and there is still some noise visible. If I zoom in on the frame, you can see that these walls are still pretty noisy. So I know from experience, in order to get rid of the noise completely, I'm going to have to quadruple the number of Monte Carlo rays to 2048, and that means that my render times are going to certainly at least triple, and this is on a very low resolution frame. So this frame is going to render 4 times faster than my full resolution frame. So if I'm looking at 10 minutes a frame here, if I increase my Monte Carlo rays, I would then be looking at 40 minutes a frame for my full resolution, and I really can't afford this. Because I'm rendering this project at home, I'm really aiming for around 15 to 20 minutes per frame. Now, an interior such as this one is really a notoriously difficult case for global illumination because all of the light is coming from the windows. And in terms of the entire environment, the windows are relatively small. And when you have relatively small sources of light in an environment, you need more global illumination rays in order to get a clean render. So in order to help with the global illumination calculations, I've got a really good optimization which I'm going to show you. This involves placing a spherical camera where the subject is, and then hiding the character and the table, and using this spherical camera to do an HDR render of the entire scene. And we'll use this HDR render to help us optimize the GI. I'll show you how it works. So I'm going to return to the scene, and in the item list, I'm going to add a new camera. And let me just go back to my perspective viewport. What I'm going to do is I'm going to grab this camera and I'm going to place it roughly where the character is. So let me just get a good view of him. And let's grab the move tool and place it roughly here. And I'm just going to rotate it 180 so it's facing the other way. And I'm just going to rename this to camera HDR. And with that done, I'm going to hide the mesh for my character, and I'm also going to hide the mesh for the table. So I've selected it in the 3D viewport, and hovering over the item list, I'm going to hit the F key and that will locate it in the item list for me, and then I'll just hide it. So the next thing I need to do now is go to my render item and change my render camera to be the camera HDR, which I've just created. And now I need to create a frame size which is twice as wide as it is high. So I'm going to go for 2000 by 1000. And now I'm going to unpause preview to see what this gives us. So at the moment this isn't quite right because there's one more step I need to do. I need to select my camera HDR, and where it says projection type, I need to change that to spherical. And if I unpause preview once again, hopefully this time the results will be a little better. And here is the result. So you can see that I've got a really nice spherical panorama now of my set. I just want to do one small tweak to it before I go any further. I think it'd be nice if, as well as the sunlight coming into the room, there was a little bit of blue light from the environment, say from a blue sky. So I'm just going to pause the video while I add an area light to this window here. So I've placed an area light in this window. I haven't done the same in the other window because the other window is never actually going to be seen in this shot, so I don't really need to add a second area light here, because every area light that you add to a scene is going to fire more rays, and the more rays you fire, whatever their source, is always going to increase your render times. So you can see I've given a sort of bluish color to the light, and I'm just going to unpause preview so we can see what it looks like. And you can see as preview updates, it just adds a bit of complexity and a little bit of extra realism to the environment. So I think I'm definitely going to use this. Now you can see I've also opted to preserve the volumetrics which I applied to the sunlight, because I think that would be quite a nice touch to have in the HDR. Now because I'm rendering a still and not an animation, it's perfectly okay to use irradiance caching for this render. So what I'm going to do is go back to my global illumination settings, and I'm going to set my irradiance caching for the first and second bounces, and I'm going to increase the quality to 1024. I'll reduce the Monte Carlo rays to 64, not that it will have any effect anyway, and then I'll increase my indirect bounces to 6, and having done all that, I'm going to render this image. And here is the completed render, and obviously with irradiance caching it renders very quickly, 6.5 minutes even with 6 bounces. Now there is some banding in the volumetrics, but I'm really not worried about that because we'll never see this image directly. It's simply there to help us with the GI calculations. So what I need to do now is to save this image as a 32-bit EXR. So I've selected that as my file format, and I'm going to overwrite this file that I'd already created. So now I'm just going to go back to my scene and reset everything how it should be. So I'm going to reset the camera, reset my dimensions to how they should be, go to my GI and set my IC to be the second bounce only. I'm going to reset my irradiance rays to, actually I'm going to set them to 512, and there's something I need to explain about using irradiance rays on the second bounce only. There's a property in the channels of the render item which is, let me just show you, secondary rays, and it defaults to 25%. Now, if you have your IC set for the second bounce, this is actually the value that it's going to end up using. It's going to be using 25% of whatever you have set here. So just bear that in mind. If you're using IC for your second bounce only, you should either set this value in the channels to 100%, or just remember that you'll only be using a quarter of the value that's actually set here in the render properties. So although I've actually set my radiance rays here to 512, on the second bounce I'll only be using 128 rays because that's 25% of 512, and that's actually quite a low quality setting, so I'll have to keep an eye out for any potential flickering in the renders. Now I'm going to go back to my Monte Carlo rays and I'm going to set those to 1024, and I'm going to set my bounces back to 2, and finally I'm going to go to my indirect range and limit that to 2 meters. And this is the crucial setting, because when you limit your indirect range, what happens is that once the GI ray has traveled by whatever value you have set here, it's going to terminate and it's going to return with the environment value. And this is where we're going to use our HDR to help us. So now I'm going to go to my environments and I'm going to expand them, and I'm going to go to the item menu and I'm going to go create environment, and that's going to add a second environment. I'm just going to quickly rename it to environment GI, and then I'm going to expand it again and I'm going to add an image. So I go to add layer, image map, load image, and then I'm going to go to my texture folder and I'm simply going to load the HDR file that I've just saved. And if I go to the texture locator, I need to make sure that it's spherical in the Y and then it's set to environment color. So with my image in place, I now need to ensure that it only affects the GI and nothing else. So I'm going to untick visible to camera, visible to reflection rays, visible to refraction rays. And I'm going to go to my original environment and untick visible to indirect rays. And now everything should be set up correctly. So before I do a test render, I'm just going to have a look in preview first. So that looks pretty good. So I'm going to go back to my render frame, and once again I'm just going to divide the frame size by 2 so that I can compare it with the previous renders, and I'm going to do a test render now. And here is the completed render. It's coming at 5 minutes 24 seconds, which is 2 minutes slower than the render using GI without the HDR, which came in at 3 minutes 22. But if you look at the difference in terms of GI noise, especially on this back wall, you can see the extra render time is really worth it, because the render is now completely clean, and without using the HDR I would have never got such a clean render in such a short time. And the trick of limiting the GI to 2 meters and then using the HDR environment has also brightened up the background. Essentially it's faking the look of additional bounces, which is also quite useful. Now there seems to be a bit of a weird light shining on the character's face, and I'm guessing that's because I had the volumetric in the HDR that was used in the environment. So at some point I'm going to try a different version without the volumetrics baked in, but I think for now this is good enough. And I think what I'd like to do is to do a render at full resolution of the entire sequence just to see where I'm at. So I've done a test render of my sequence, and it's taken roughly 20 minutes a frame, which is pretty much at the outer limits of what I can afford. So there's lots of problems with the render that's come out, and that's not surprising. I'd always expect to be quite a few problems in the initial test. But as I go through to fix the problems, I have to be sure not to let my render times increase too much, because I really want to try and keep the render times as low as possible. One of the challenges that you'll encounter when rendering animations is that you often need much finer anti-aliasing than you would for a still. If I put this preview at 100% and we have a look at the anti-aliasing on the floorboards, you'd probably think that it was adequate, and for a still it almost certainly is, but as soon as I press play, you're going to see there's quite a lot of flickering, and this is something that you're going to encounter quite a lot. Any high contrast surfaces, especially ones that use bump maps, are always going to need very fine anti-aliasing when they're animated, just to avoid this kind of flickering. But that's not the only problem in the scene. If I press play once again, we can see there's problems with the background objects. There's definitely some flickering going on there. It's partly masked by the volumetric light, but I'm definitely going to need to look at those areas. There's also what appears to be a little bit of flickering in the table and on the reflections of the character. And also, more obviously, the quality of the volumetric light isn't that good. I can see a lot of grain, but that is something that I can fix in Nuke because I've got the volumetric rendered on a separate output. So it's not going to be difficult to isolate that and blur it separately. I also find it's very useful to look at different render outputs in order to diagnose problems. So I'm going to go back to my thumbnails and I'm going to load the global illumination output and maximize that. Now if I play the sequence, I can have a look at the Monte Carlo noise, and I would say that in terms of noise, the Monte Carlo and GI is really good. I'm quite happy with this. I can see there's a tiny little bit of a radiance cache flickering going on in this corner, but once again I'm not particularly worried about it, because once the volumetric light is in and the textures are in, I don't think this will be particularly visible. However, a more serious problem is the flickering that's going on these objects here at the back, and this is being caused by the bump maps. So what I'll probably end up doing is simply to disable these bump maps on these props, because these props aren't important to the shot. It's the character that's the focus. So instead of assigning a finer shading rate to these items and slowing down my renders, I'm just going to disable the bump maps, because that will be the most efficient thing to do. I can also see there's a bit of flickering going on the bump mapping on this table leg, and this I will go and fix, because obviously the table leg is going to need some bump mapping, because it's something that's in the foreground and it's relatively important in terms of the shot visually. So I can see that from this initial test, my global illumination is working reasonably well. However, I've got a few anti-aliasing problems to solve. So this is what I'm going to have to do when I go back to the scene, is to look at shading rates and anti-aliasing. And obviously increasing the quality of the anti-aliasing is going to mean that my render times are going to get longer. But because my GI is working so well, I may be able to reduce the quality of the GI in order to compensate for this. So I've returned to my scene, and the first thing I've done is to add a spotlight to help pick out my character's head. Because it's the focal point of the shot, I felt it needed a little bit of extra light. Now personally, I'm not one of these artists that goes and adds 20 lights to every shot. It's not really how I like to work. I like to add the bare minimum of lights that I can get away with, and this is for a couple of reasons. First of all, the more lights you add, the more rays are being fired into the scene and the longer your renders are going to take. But secondly, and I feel quite strongly about this, I don't like adding a huge number of lights to a CGI shot, because it just feels very unnatural to me. It feels very artificial. I'd like to try and think more like a cinematographer who's lighting a live action shot. So in this case, I add lights specifically to help tell the story, but I don't then go and add extra area lights to fill certain areas, or add artificial rim lights to every single character. I mean, in this shot, there's obviously some rim lighting which is naturally coming from this window, but in other circumstances, I wouldn't necessarily go and add a rim light just to help pick out a character. It just doesn't feel like the correct way to go about things. So I prefer to try and keep things simpler and to try and be more deliberate in my lighting choices. But obviously, storytelling is the #1 consideration when you're lighting. Now I know I'm going to need to increase the quality of the anti-aliasing, especially on these wooden surfaces, in order to solve some of the problems that I encountered in my test render. So in order to try and offset the increased render time, I'm going to go to my global illumination settings, and I'm going to reduce my indirect rays to 256, in the hope that that's going to claw back some render time that I'm going to otherwise lose by increasing the quality of my AA. Before I start working on the table and the floor, I'm going to deal with these ornaments on the shelves here at the back. Now for these, as I said earlier, I'm simply going to disable the bump maps, because they're so far away from the camera and so unimportant to the shot in terms of story that the detail that's being added by those bump maps just isn't important enough to add to my render times. So by disabling the bump maps, I'm going to be able to increase my render quality without actually increasing my render time at all. So I'm going to locate them in the shader tree. And luckily they're all in this folder called ornaments. So I'm going to hold the shift key and expand the folder. And by holding the shift key, it will also expand all the subfolders underneath. And with the folders expanded, it's a simple case of going through and looking for all the bump maps and simply turning them off. Now obviously it's going to take me a few minutes just to go through and turn every single bump map off, because there's quite a few ornaments. So I'll just pause the video while I'm doing this. So I've gone through the shaders that are assigned to all of the ornaments and turned off all the bump maps, as you can see here in my list. Now this is obviously a very cheap way of solving my problem, but in this case it really was the best approach, because it really isn't worth spending the extra time and effort and also the extra render time cleaning up the bump maps on these ornaments. So the next thing I'm going to need to do is to look at my global anti-aliasing. And I'm going to go to my render settings and go to anti-aliasing. And to start with, I'm going to see if 32 samples per pixel is enough. And I'm also going to change my refinement shading rate to 0.5, just so there's a little bit less refinement shading going on, because that will help with the render time. And it will also help with potential noise, because refinement shading can sometimes add noise when you've got these complex shaders like I've got in here, especially with the wooden surfaces. And the next thing I'm going to look at is the shading rate on the floor and on the table. So I'm going to expand the workshop shading once again. And I can see that the wooden tabletop has already got its own shader above the base shader. And the shading rate here is already set to 0. That was something that I did when I was actually creating the set in the as an asset. And I'm going to look at the shader for the floorboards, which also have their own shader. Now that's got a shading rate of 0.25, but I'm also going to set that to 0 because I want it to be controlled by the global anti-aliasing settings. And having done that, I'm also going to look at the reflection rays in the material, because a lot of the noise was happening on these reflective areas. So it's probably a combination of anti-aliasing and reflection rays that was causing the flickering. So I can see that I've got them set at 256 on the floorboards, and I'm going to multiply that by 4. And next I'm going to look at the wooden tabletop, and I've got that set at 512. I'm going to leave that there just to see if that's enough, if I can get away with that. Now the actual legs of the table, I've got a completely different material assigned to them. So I'm going to locate that in the shader tree, and here is the group. And what I'm going to do is I'm going to assign a custom shader to that group. So I'm going to drag it above the base shader, which is in the workshop shading, and I'm going to expand that and assign a custom shader. So I'm going to go to special shader, and just as before, I'm going to set the shading rate to 0. Now at this stage, I'm ready to do a test render to see if the adjustments I've made to the shading on these table legs is good enough to solve the flickering problem that I was seeing in my test render. So what I'm going to do is I'm going to open the render window. And the last render I did was of the entire sequence, so it's displaying the final frame here. So what I'm going to do is define a render region around the table leg, and I'm going to make sure that that render region is being used. And now I'm going to do a test render of just 10 frames. Now because there's a camera move in this shot, and I drew my render region around the final frame, it makes sense to do my test render of the final 10 frames just to make sure that the table leg is actually in the defined render region. So I'm going to go 90 to 100, and I'm going to click OK. And I'm just going to create a new folder called bump testing. And in this folder, I'm going to save my test as 16-bit EXRs. And I'll just pause the video while this renders. So my test render is complete, and because I drew a limited region, it only took 3.5 minutes. I've got the outputs open in Hero now, so what I'm going to do is I'm going to maximize my preview and press play, and I can see there's still a bit of swimming going on the texture. And in fact, if I look at the GI output, it's even clearer. You can see there's really still quite a lot of noise. So I don't really want to increase my global AA any more than I already have. So what I think I'll do is I'll just reduce the strength of the bump map to try and work around this problem. So I'm going to switch back to Modo and then go back to the scene and locate the material for my table legs. What I'm going to do is I'm simply going to divide the bump amplitude by 2, and having done that, I'm going to fire off a second test render. So my latest render is complete, and it was actually 10 seconds quicker than the previous test render, and that's because I didn't really change any quality settings. I just reduced the strength of the bump map, which is a bit of a hack, but it's a very efficient way of dealing with the problem because you're not increasing your render time. In fact, you're improving your render times because there's less shading going on. So I'm going to switch to Hero, where I've already loaded in the latest renders. Now when you do these tests, it's important not to overwrite files. You want to always increment, because that way you can compare one version against another. So what I'm going to do is I'm going to get my latest render and load it into the B slot, and then I'm going to maximize my viewport, and I'm just going to get a swipe and swipe between. So what you're looking at is the original, and now you're seeing the latest version. You can see it is definitely slightly cleaner, and if I just press play, well, there's still a little bit of noise going on with this render, but I think I'm going to leave it for now and see how it looks once the sequence is rendered, and also once we've added the depth of field and all the other effects are going to be there in the grading, because they might help to mask some of the noise problems. And the reason why I'm reluctant to do anything more in terms of the quality of the shading on this table leg right now is simply because the shading rate is already set to 0. So to get any higher quality than what I've got here, I'm going to have to increase the global AA, and that's obviously going to have a bigger impact on the render times for the entire shot. So it's probably something that I may have to do later on, but I'm reluctant to do it right now because it's a global setting. It's going to slow down my render time, so it's something that I'm going to approach with caution. So I'm going to switch back to Modo now and return to the scene. Before I do that, let me just disable my render region. And I was having a little bit of flickering on the upper arm part of the character here, and also on his knee. So what I'm going to do is I'm going to locate the materials that are assigned to those parts. So the first one I need is upper arm left. So let me just locate that, upper arm left. And I'm going to go to the material settings. I'm not going to touch the anti-aliasing just yet, but I'm going to set the reflection rays to 256. And then I'm going to do the same to his lower leg left. So there it is, lower leg left. That's where the knee joint was flickering slightly. I'm going to set this to 256. And the next thing I want to do before I do any more testing is to look at my environment, because if you remember, the environment which is visible to reflection rays is still clamped. And I think that these reflections probably need to be just a little bit stronger. So what I'm going to do is I'm going to unclamp the sky brightness, and let me just unpause preview so we can see what that looks like. Now obviously, just as before, I find the unclamped sky gives me reflections that are way too strong. So what I'm going to do is go to the environment and set its intensity to 0.2, and I'll unpause preview again to have a look. And this seems to work much better. I've still got some quite strong reflections, but they're just not as over bright as they were with the intensity at 1. Now, I know the scene isn't ready. There's still quite a lot of tweaking to do, but it's the end of the working day here. So I'm going to make good use of the render time that I've got available to me overnight, and I'm going to fire off another test render of the entire sequence, and I can have another look at it in the morning. But before I render the entire sequence, I think I'm going to do a test render of just one frame, just to see if my render time has increased or decreased with the changes that I've made. And because this is still a work in progress, in order to speed up my overnight render times, what I'm going to do is I'm going to disable some of my render outputs. For example, I don't need the volumetric scattering because I've already rendered that in the test yesterday, and I haven't made any changes to the volumetric, so I can just pull in the old volumetric output render. I'm going to disable the bloom as well, and I'm going to disable the technical passes with the Z depth and the motion vectors, and I'm just going to test one frame now. And here is my completed frame, and it's rendered in just under 10 minutes. Whereas when I rendered the sequence previously, it was taking 20 minutes a frame. So you can see that I'm being very cautious in terms of my render time. So while I've definitely improved the anti-aliasing settings, I've also clawed back a lot of time by making the GI calculations a lot coarser. Now I'm sure I'm going to have to do some further tweaking, but I think this is a good point at which to do a render of the sequence and just see where I'm at. So with my latest sequence now rendered, I'm ready to compare it with the previous render. So I'm going to put the old render in the B slot, and I'm going to maximize my viewer and activate the wipe. Now ignore the fact that I didn't render the volumetrics this time because I wanted to save time. You can see as I wipe over that in the floor, even before I press play, we can see that the anti-aliasing has definitely improved. You can also see that the reflections are much more interesting now that I've unclamped my environment. I've got a bit of blue in the latest renders, which wasn't in the old renders. Now, if I play the sequence, I can see there's still some flickering going on in the floor. I'm not particularly surprised. I've got my global AA set at 32, and I'm probably going to have to set it to 128, I would imagine, in order to get a fully clean render. But because I've dialed back on the global illumination, I've got quite a lot of leeway because the latest test was rendering at 10 minutes a frame and my target is 20, so I can probably still increase the settings. So I'm going to disable the wipe and just have a look at the latest render on its own. Now I can see there is still a bit of icy flickering. That's something I might have to tackle, but as it's behind the volume light and probably going to be blurred out by depth of field, I might get away with it. The floor, as I know, has got some flickering. The table's got some flickering. There's a little bit of flickering going on the character. And there's a bit of flickering going on his face, and because his face is so important to the shot as it's the focal point, I really will have to clean that up. Also, the Monte Carlo noise is static because the animated noise channel is still set at the default value of off, which means I'll have to turn that back on. And I can see that the ornaments on the shelves, although the bump mapping is gone so I don't get the crawling effect I had from the bump mapping before, still causing me problems in the highlight region. So again, there's more work to do here. But before I go back to Modo and start tweaking the settings and increasing the quality everywhere, I think the best thing to do at this stage would be to go into Nuke and to do a rough comp, because once I've got some depth of field and the volumetric properly integrated into the shot, I'll have a clearer idea of where I really need to concentrate on increasing the quality. So I'm going to switch to Nuke and I'm going to hit R on the keyboard to open my read files node, and I'm going to pull in all of the render outputs which I've rendered with my latest test and going to lay them out very quickly. Let me just pause the video while I organize this. So I've quickly laid out my output nodes in Nuke, and if I select the final color output and hit 1 on the numeric keypad, that will load it into the viewer. Now, as this is just a rough test, I'm probably going to work directly in the final color output, but I'll also show you how to rebuild the final color output using separated shading outputs. So if I zoom in here, these are the nodes that you need to add together in order to rebuild the final color. You need the diffuse shading indirect, the diffuse shading direct, the reflection shading, the luminous shading, the transparent shading, the subsurface shading, and finally the specular shading, and these need to all be added together. It's important to avoid using multiply operations when you're compositing because you can get fringing where the anti-aliasing is going to give you multiplied pixels which are going to come out with illegal values. So I'm going to quickly merge all these nodes together. So I'll select the topmost one and hit M to create a merge node, and I'll zoom in so you can see a bit more clearly what's going on, and I'll connect the B output to the next node down, and I'm going to set the operation to plus, which is the same as add, and then I'm going to add another merge node and connect it to the next output, and once again I'm going to set the mode to plus and keep hitting M. I'll just pause the video while I connect the rest of the nodes. So I've merged all my nodes together, and I'm going to select the last merge node and hit my 2 on my numeric keypad, and this is going to switch my viewer to it. So if I switch between the final color and the remerged nodes, you can see I'm getting a slight inconsistency, and I think this is because I've been using the iridescence shader on the metallic parts of the robot, but I've been using that shader with an opacity of 10% to give a more subtle effect. So you can see that if I look at my final color and I zoom right in, basically there's a tiny bit of iridescence here because the shader's at 10%, but when I switch to my rebuilt nodes, I'm getting the same iridescence shader applied at full opacity, and my feeling is that the opacity of the shader is being ignored in the reflection shading output, and that's why I'm getting this inconsistency between the two. But with a bit of grading, I'm sure I can fix the problem. So I've added a grade and a saturation node to these outputs, and I'm sure if I play with them, I can get something pretty close to what I was getting in my final color output. So if you remember, in order to save time, I omitted the volumetric and the depth output from this latest render. So what I'm going to do is I'm going to import them from the previous render. So if I go to my original sequence, I'm going to locate the volumetric scattering, and then I'm also going to locate the depth output, which is here. And they haven't really changed in between, so it should be no problem using the old renders in this test. So in order to comp my volumetric on top of my final color output, let me just zoom in for a second. I'm going to add a merge node to the volumetric, and then I'm going to connect it up to my final color. Let me just connect my viewer to it, and I'm going to set the operation to plus, and you can see that that's comped the two together. And the next thing I need to do is to get this depth output and merge it with the result of this comp here. So in order to do this, I'm going to need a shuffle copy node. So if you've never used Nuke before, the shuffle and the shuffle copy node are a little bit mysterious, but don't worry, I'll explain how they work. So I'm going to hit the tab key so I can do a search, and I'm going to search for shuffle copy. And what this is going to allow me to do is basically take this image, the result of this merge operation, and simply add this depth channel to it. So the first thing I need to do is simply to connect the shuffle copy to the merge node, and I'm also going to hit the 3 key on my numeric keypad, and this is going to point my viewer towards the shuffle copy node. And if you look at this panel up here in the top right, this has the interface for the shuffle copy node. Now it looks a little bit intimidating at first, you might be wondering what's going on, but it's actually very simple. We're basically asking it to input a certain number of channels, and then we choose from the 2 inputs which channels we're then going to output. So as it happens, we want the RGB to come from the merge node, which if I zoom in is output 1, not output 2. And we want the depth to come from the depth output RGB. The shuffle copy node is laid out as a grid, and it's in this grid that we determine from the channels that are coming in which of those channels should then go out. So in this particular case, we can see from these 3 crosses that we're getting the RGB channels from input 2, and we're outputting those as the RGB channels that are output from the node, which is why we've got the incorrect image displayed in the viewer here. Because in this case, input 2 is our depth channel, and we don't want to be outputting the RGB values of our depth channel as the RGB values of this node. We need the RGB values to come from this merge plus operation here, where we composited the volumetric light on top of the final color output. So there's 2 ways that we can fix this. We can simply just tick these boxes to channel the RGB channels from our input 1 as the RGB channels that are output by the node. Or if I go back to how things were, I could just select the shuffle copy node itself and hit Shift X to just swap the 2 inputs around. And as you can see, either of these methods will then output the correct RGB channels from the node. And then all we need to do is to fix the alpha channel and the depth output. So I'll select the alpha channel from our input 2, which is now our merge plus node, and I'll just tick that box to make sure that that's the alpha channel coming in from here, which is output here. And so finally, to now define the correct depth output. Now my depth output is saved as an RGB file, not a Z depth file. So what I need to do is in the second output from the shuffle copy node, I'll go to other layers and select depth. And you can see that now adds a Z output channel to my node. And all I need to do now is from the depth output that's been rendered out of Modo, select any one of the RG or B channels as my output. And here you go. This is now correctly set up. And I can check in the viewer to see if everything's been correctly set up. Since the viewer is currently pointing at the shuffle copy node, I can see all of its outputs. So here at the top of the viewer where it says RGB alpha, I'm going to select depth Z, and then instead of RGB, I'm going to display the alpha, and this is now showing me the depth channel. Now you might think that it doesn't look as if it's showing any depth information. This is simply a question of exposure. If I bring the exposure down, you can see that indeed the depth channel is correctly displayed. So now that I'm confident that everything is working as it should, I'm just going to set my viewer back to what it was. So now that I've got my depth output successfully merged into my RGB comp, I'm going to add a Z defocus node. So I'm going to go to Filter, Z defocus, and I need to set the focus point. So I might need to go and locate the focal point and simply set it on my character. And you can see as soon as I do that, we've got the depth of field effect now in the shot. So having done that, I'm just going to maximize my viewer by hitting space. And let me just drag this into the middle of the screen. And obviously with the depth of field applied, we can see that the noise on the back wall is much less of a problem, and so is the noise that we're getting on these shelves. Same can be said for the noise that's behind the volumetric light on the floor. So it's important to do a rough comp before you do any serious troubleshooting, because you can see that it's important to concentrate your attention on areas that are going to be clearly visible in the final shot. And also, before I return to Modo, I'm going to have to make a decision about the depth of field itself, because one of the drawbacks of doing the depth of field in post is that it's very hard to get accurate results, especially if everything is in one pass. So if I zoom in, you might see what I'm talking about. There's a very strange transition on the head of the character between the part that's over the background and the part that's over the table. It just seems very unnatural, the way that this edge is very soft and suddenly this edge is very hard. Now, if I take the volumetric light out of the equation by just switching the input of my shuffle node, you can see this more clearly. It's not related to the volumetric itself. You can see that there's an unnatural transition here, and the way the softness of the head changes from very soft to quite hard is quite unnatural. I have two solutions to this problem. Unfortunately, both of them are going to increase my render times considerably. The first solution is to take the character and the table and to render them completely separately from the background in a different pass. That's obviously going to increase my render times, but it means that when I do my depth of field in post, I'm going to have a lot more control. The other solution is to try and do the depth of field in Modo itself. That is also going to increase my render times, because obviously I'm going to need a lot more anti-aliasing in order to get clean results. The other drawback of this approach is that it's going to take away some control in post, and generally the most common workflow is to try and do the depth of field in post. However, one big advantage of doing the depth of field in the render itself is that it's always going to be more accurate, especially if you've got transparent objects in the scene. So I'm now back in Modo, and there's a few changes I'm going to make to the scene in order to try and improve the results that I've been getting. So in order for my tests to complete more quickly, first of all I'm going to divide the frame size by 2 and hold down Control Enter to make the change proportional. Then I'm going to go to my settings, and I'm going to need to increase my global AA, so I'm going to try 128 samples per pixel. And next, with my render item still selected, I'm going to go to the Channels tab, and I'm going to look for the animated noise channel, because if you remember, the noise was static from frame to frame, and this is quite distracting. So I've located it here in the channels list, and I'm just going to set it to true, and that means that we'll get a more natural grain-like effect in the frame to frame of the animation. And next I'm going to have to do something about the flickering on the character, so I'm going to select the Android shading group in the shader tree, and I'm going to set the shading rate on him to 0. I'm hoping that will be enough, and that I won't need to go through and increase the ray count on the reflection rays on all the materials. Now the floor and the table are probably already taken care of, because their shading rate is set to 0 already, and I've just increased my global AA to 128. So in theory that should be enough to deal with the noise that I'm getting in the wood materials. And the final thing I need to look at is the ornaments that are on the shelves. So they're inside their own group at the bottom of the workshop group. So what I can do is I can put a shader at the top of this group. So I'm going to go to Special Shader, and I'm going to set the shading rate on that shader not to 0, but I'm going to try 0.1. So that will limit it to 100 samples per pixel. Now obviously I'm going to need to mask this group that all the ornaments are in, because at the moment it's just an organizational folder, and this shader over here is going to override this one. But fortunately there's already a group I can use for my item masking, because in my workshop modeling all of the ornaments are already inside a folder in the item list. So all I need to do is to select this group in the shader tree and to item mask it to this group in the item list. So with my shader tree folder selected, I'm going to go to the item field, and I'm going to scroll right down to the bottom where all the folders are found, and I'm going to make sure that I select the correct group. So the one that I'm looking for is the ornaments in the modeling. So there it is. So that is now correctly item masked, and all I need to do is to collapse the group and then to drag it above the base shader. And with all that done, I'm now going to do a test render. So my test is rendered in 6 minutes and 25 seconds, which is a little bit slow for my liking because this is at half resolution. So at full res, it's going to take 4 times longer, which means I'll be looking at 25 minutes a frame, and that's without the volumetric light, which is also going to add some render time. So we could be looking at half an hour a frame, and that's a little bit slow for a project which I'm rendering at home. Now what I'm going to do is I'm probably going to go back to the shader that I added to the ornaments and just make it a little bit coarser because that might help with my render times. However, I'm a little bit concerned about the reflections on the wooden floor and on the table because they look slightly grainy still, so I think I'm going to need to increase the number of reflection rays on those. So first of all, I'm going to return to the scene and I'm going to go back to the shader that I added to the ornaments, and I'm going to set the shading rate to 0.25. So that's a little bit coarser than the shading rate I had then. And then I need to locate the floorboards and go to that material. And I'm going to need to at least double the number of reflection rays, I think. And I'm also going to go to the wooden table, which is here, and I'm going to do the same. I'm going to multiply this by 4 so that we get 2048 reflection rays here. And there's also the concern I had with this strange looking bounce light on the character's face. Initially I thought it might be caused by the HDR that I'm using in the environment, but actually I've since discovered it's just the spotlight that I use to highlight the character's face is badly positioned. So if I look through the viewport, looking from the point of view of the spotlight, I can see it's cutting off the top of his head. So if I just move it so it's in a slightly better position, and what I'll also do is just widen the cone a little bit. So let's make the cone angle maybe 16 degrees, just so it's got a little bit more leeway for when the character moves his head from the table to when he's sitting up. Hopefully that's going to fix my problem. So what I'm going to do is I'm going to unpause preview and look at the results. And with preview updated, you can see that it looks a lot more natural now. I think the spotlight's probably a little bit strong, so I'm going to reduce the intensity to just 5. And once again, just see how that looks in preview. It should be subtle enough that you don't really notice it. It's just so that his face stands out in the frame. I think I'm happy with that. So before I do anything else, I'm going to try doing a test with depth of field actually rendered in Modo and just see how long that takes to render at half resolution. So I'm going to locate the camera which it came in with the referenced animation. I'm going to temporarily unlock it, and I'm going to go to the camera effects tab and enable depth of field, and I'm going to unpause preview. Going to take a little while to update. I might just pause the video while it updates. And with preview updated, you can see the effect is quite subtle, so I'm going to reduce the f-stop to just 1 just so we can see it more clearly. And you can see immediately now things are much more blurry. And if I hover my mouse over a particular area that I want in focus over preview and then hit Ctrl F on the keyboard, that will reset my focus point to the point where I was hovering with my mouse. Now obviously an f-stop of 1 in a shot like this is way too blurry, so with that done I'm now going to set the f-stop back to 4 and I'm going to pause preview once again, and I think it'd be a good time to do a test render just to see how the depth of field is going to affect our anti-aliasing. So my render's complete, and if I zoom in I can see that my anti-aliasing is actually holding up surprisingly well. Obviously, in such a small frame, you can see when I compare with the previous frame, the depth of field effect is very, very subtle. But when I render at full resolution, it'll be much more obvious. So what I'm going to do now is I'm going to re-enable the volumetrics, and I'm going to do another render of the entire sequence. So my latest test render of the sequence has rendered out, and this is the one with the depth of field rendered in Modo. Now because I already had 128 samples per pixel in my global AA, and the depth of field effect is quite subtle, the anti-aliasing seems to be rendering just fine. However, if I play the sequence in Hero, you can see that there's still a number of issues to deal with here. So let's go through them one by one. The most serious issue is this flickering I'm still getting on the floor. It's better than it was before, but it's definitely still there. And this is almost certainly because of my blurry reflections. I've also got a bit of flickering on the table. For the most part, the character is now okay. His face certainly is rendering more cleanly than it was before. I'm still getting a little bit of flickering on this knee joint, and that's because I dealt with the lower leg, but I think I also need to increase the blurry reflections on the upper leg as well. Now if we have a look at the GI, you can see that now we've got the animated noise, we've got a different pattern on the wall, and it is flickering more visibly, but this is something I can deal with in Nuke very easily, so I'm really not concerned about that. However, I am a little more concerned about the IC flickering in this corner. I think I'm going to need to increase the IC samples in order to get rid of it. Finally, most of the props on the shelves are now rendering cleanly, except for the very thin bits of metal that we've got on the glasses here and on this on these scales here. And this is a pure anti-aliasing problem. It's because these have got sharp reflections and they're rendered on very thin objects. So there's two things I could do. I could assign a finer shading rate just to those two materials, or more likely, I think, because they're so unimportant to the shot, I think I'm simply just going to reduce the actual reflectivity of those two particular materials. So the most serious challenge is this noise on the floor. And when you're faced with a problem like this one, it's important to try and be very careful. You don't really want to start maximizing all your settings. This is where you have to be very specific in targeting the right setting in order to solve your problem. So in order to help me with the diagnosis, I've pulled in a few extra rendered outputs, and I'm going to have a look at the diffuse shading to start with. And I can see that when I play that, the anti-aliasing on the diffuse shading is absolutely fine, and I've also got the indirect shading. And again, I can't see any anti-aliasing problems here. When I look at the reflection shading, and this is where I'd expect to see the problems, and indeed this is where the flickering is occurring. Now, it could be a combination of anti-aliasing and reflection rays that's causing the flickering, but my hunch is that it's more likely to be the reflection rays rather than the anti-aliasing. So I've switched back to Modo, and I'm ready to tackle the noise on the floor. So I'm going to select the material that's applied to the floorboards, and I'm also going to select the material that's applied to the wooden tabletop. And in the blurry reflection rays, I'm going to increase the ray count by a factor of 4. So I'm just going to type multiply by 4 in the dialog to give me 8,192 rays. Generally, when you have a visible noise problem, increasing the sampling by a factor of 2 isn't usually enough. You usually find that you have to increase it by a factor of 4 in order to get a clean result. Another potential source of noise in this scene could be the ray threshold, because there's a certain amount of recursive reflections between all the various objects in the scene. So I'm going to go to the render item, and in settings I'm going to decrease the ray threshold by a factor of 10 by adding an extra 0 after the decimal point. So by decreasing the ray threshold, more of the secondary rays will be preserved. That means that when reflection rays hit a surface, they're less likely to be killed off by the importance algorithm. So having done this, it's time to do a test render. I've already defined a render region, so I'm just going to pause the video while I render this test. So with my test render complete, we can compare the results with the previous frame. So my render region is defined in this area here, and you can see that when I compare it with the previous frame, the noise is visibly better now that I've increased the number of reflection rays and reduced the ray threshold. Now, it looks pretty smooth in a still. It's possible that when the sequence is actually rendered in animation, that there'll still be a little bit of crawling along. But at this stage, I think any problems that remain should be fixed in Nuke. So I'm going to return to the scene now, and the next thing I'm going to look at is the flickering on the character's leg. So I'll collapse the workshop shading and expand the character. And I increase the number of reflection rays on the lower left leg, and I think I need to do the same on the upper left leg. So I'm going to locate that material and go to the reflection rays, and I just need to refresh my memory. What did I put in the other one? 256. So I'm going to do the same here, put 256 reflection rays here, and that should hopefully take care of the flickering that's going on the knee. And the next shader I'd like to look at is the one applied to the window, because there's also some visible blurry reflection noise on there. And it's not surprising because obviously there's a very bright environment outside, so there's going to be some really high contrast reflections going on here. So I'm going to go back to the workshop modeling, and I'm going to locate the window frame material, which is here. And I'm going to increase the reflection rays to 512, and that should hopefully help to clean up the grain that I was seeing there. And next I'm going to look at the thin metallic surfaces that I had on the shelves. I'm just going to zoom into those. So there's the glasses and there's this sort of strip of metal on these scales. So if I right click on the glasses in the viewport and go to shaders, I can locate the shader that's applied to them, and it's this one here called wire. So instead of dragging that above the base shader and assigning a custom shader with a finer shading rate, I'm simply just going to decrease the reflectivity of the material. It's a complete hack, but in this case, when the asset is so far away from the camera and it's just not important to the shot, I just think it's a much more efficient way of doing it. So I'm going to do the same here on the scales. I'll go to shaders and locate the scales lever material, and I'll do exactly the same thing, just reduce the specularity of it. And the final thing I want to change in the scene before doing any more testing is to go to the render item and the global illumination, and I'm going to increase the irradiance rays. Now remember, because I'm using the IC for second bounce only, and my secondary rays in my render item channels is set to 25%, I'm only using a quarter of this value here. So what I'm going to do once again is I'm going to multiply this value by 4 so that the value in the dialog is 2048, but on the second bounce I'll only be using 512 rays. Now, when it comes to the volumetric, I wasn't actually able to render it in my last test, because now that I've increased the anti-aliasing settings, adding the volumetric to the scene, especially as I also wanted to have more samples on the volume light, was more than doubling my per frame render time. Instead of getting render times of around 25 minutes a frame, it was something closer to an hour. So I disabled it, and what I'm going to do with the volumetric is I'm going to render it in a completely separate scene with all of the geometry that's here, but none of the shading and none of the GI, etc. And finally, there's also the depth of field to consider. I thought that in the last test, the depth of field effect was too subtle, so I'm going to go to my render camera and I'm going to decrease the f-stop. So I'm going to try an f-stop of 2. And with that done, I'm just going to do a test render of a single frame to see what things look like. And so my test frame has rendered, and my render time was 43 minutes and 29 seconds, which is more than twice my target render time of 20 minutes. Unfortunately, these blurry reflections are very costly to clean up, and having to reduce the ray threshold is also quite costly because it's obviously a global setting. The other problem is that because it's an animation, in order to prevent flickering between frames, I need to have much higher sampling than I would if I was just rendering a still. The good news though is that my depth of field is holding up pretty well, and even with 128 AA samples, I think that it's clean enough. If I need to do a bit of additional blurring in Nuke using the Z-Pass, I can do that as well. But at the moment, because I actually needed the high global AA to clean up the bump mapping on the floor, I'm actually getting the depth of field here for free. The next thing I need to do now is to separate my volumetric out. So what I've done is I've saved a new version of this shot, which is going to be just for the volumetric light. And I'm going to go in and basically reset all the settings to default values, or certainly to low quality values. So I'm going to reset my anti-aliasing. I'm going to essentially disable my refinement shading. I'm going to reset my ray threshold to 0.1. And I'm going to disable the GI completely. And next I need to remove all the shading. I can't simply delete the shading in the shader tree because it's been imported as a reference. So what I need to do is to go onto the imported reference folders and go to the references submenu, and I'm going to go delete imported reference, and I'll do the same for the character. So go to the references menu, delete imported reference, and that's just going to leave me with my geometry now in the scene. You can see that all the shading in the shader tree is gone, The next thing I need to do is to delete this area light. And then I'm going to go to my environments, and I don't need any environment visible to indirect rays. I'm going to delete that. And the environment that remains, I'll just tick that, doesn't really matter. Set it back to default values. What I'm going to do is I'm going to put a constant value in here and simply make it black. I can see I've got a couple of rogue shaders in the shader tree, and these are obviously shaders that I added to referenced items, and when the references were deleted, these were left behind, so I'll just delete these. And next I'm just going to double check the base shader. Everything is at default, which is pretty much what I want, and I'm going to go to the base material, and I'm just simply going to zero everything out, which essentially means it's going to calculate really fast. And finally, I'm going to go to my render outputs, and the only render output I actually need is this volumetric scattering output. So I'm going to put this at the top of the shader tree, and I'm going to select all the other outputs, and I'm simply going to delete them from the scene. And now obviously I'll enable that render output, and I'll go to my physical sun and re-enable the volumetrics. I've got my sample set to 120. I'm going to delete this spotlight because I don't need it in this particular scene. And having done all that, I'm ready to have a look at preview. So I'll just unpause preview, and this is the end result. And basically, if I render this out on its own, I can really easily comp it back in Nuke. And the benefit of rendering it on its own is that if I render it like this in an unshaded scene, it will render much faster than if I try and render it at the same time as my beauty pass. So now I'm going to do a 1-frame test render just to see what the render time is. And here is my completed frame, and it's rendered in just 39 seconds, which is excellent. It means that I'd be able to render this whole sequence out very quickly. The only problem is there's still quite a lot of banding in the volumetric. Most of the grain is gone, and I should be able to blur the grain away, but the banding is also a result of the low sampling. So what I'm going to do is I'm going to go back to my volumetric light, and I'm going to increase the volumetric samples to 512 and do another test render. And here is the latest render, and you can see that by using 512 volumetric samples, the results are indeed much better than the previous render. The banding is still there, but it's much more subtle. However, my render time has gone from 39 seconds to 2 minutes and 26 seconds, but that's only to be expected. I'm going to try one more render, this time using 1024 volumetric samples in my volumetric light, just to see what that does in terms of quality. And here is the latest render using 1024 volumetric samples, and you can see if I compare it to the previous one, the banding is once again much better. My render time has doubled and now it's just under 5 minutes, but I think this is a price worth paying because grain is actually very easy to blur out in post, but banding is much harder to get rid of. And the benefit of rendering this out in a completely separate pass is I only ever need to render it once. I have the first 20 or so frames of my latest sequence rendered out, and I'm going to play it in Hero so that we can see what it looks like in terms of noise. And you can see that the flickering on the floor is now much better. There's still a tiny little bit of flickering left in this area here, but it's very subtle, and at this stage it's not worth going back to Modo and trying to increase the quality settings any further than we already have. It'll be much easier to get rid of this tiny amount of noise in Nuke. Now there's also still a little bit of irradiance cache flickering going on in this corner, but once again I'm not worried about it at all because it's going to be concealed behind the volumetric light. Now there's also some Monte Carlo noise dancing around on the walls, but as I've already said, this is going to be really easy to get rid of in Nuke, so once again I'm just not worried about it. So in terms of actual quality, this render is now ready. So the next thing I'm going to do is do a quick pre-comp in Nuke so we can see how we can deal with the remainder of the noise. So I've switched to Nuke and I've done a quick pre-comp by adding all my shading outputs together to give this result that you see here. And I'm going to show you how to deal with the noise. So let's start with the Monte Carlo noise that we've got on the back wall. So this is all going to be in the indirect pass. So if I switch to the indirect shading pass, let's just switch a viewer node to this. This is my shaded GI pass, and you can see that this is where the Monte Carlo noise is going to be found. So I'm going to select the shaded indirect node, and I'm going to add a filter denoise node to it, and our viewer is now pointing to that. And in order to get even better results, what we can do is that we can use the unshaded indirect lighting output to give us a profile for the noise. So let me just zoom out of my viewer to start with and drag it round. And then I'm going to point my viewer towards the unshaded indirect node, and I'm going to drag the little square that we've got here to define an area where I want the noise to be profiled. So this seems a good spot. Now obviously the bigger I can make the area, the better the results are going to be. And then if I zoom in onto the denoise node, you can see that we've got an arrow saying noise. So I'm just going to point it to this image, and it's now going to use this output for the profiling and then clean the shaded output with the profile it gets from the unshaded output. So now if I switch my viewer back to the denoise, let's do that, you can see, and it will be clearer if I zoom in, that it's now much smoother. If I hit D on the node to disable it, just to switch between inactive and active, you can see that it's doing a pretty good job of removing the noise. And because we're only working on the indirect shaded output, we're not going to be doing any damage to any of the other outputs, which means that we're going to preserve as much quality as we possibly can while still doing a very good job of cleaning up the noise. So you can see that even with quite heavy Monte Carlo noise, it is actually very easy to clean up. And we can do a very similar trick on the remainder of the noise that we've got on the blurry reflections. So this time I'm going to select my reflection output, and I'm going to point a viewer towards it, and I'm going to go and add another denoise node to it. Now I don't have another node that I can use as a profile for this one, so we're going to have to use the same one. And what I'm going to do is I'm going to drag this little box into that problematic corner here just under the table, and I'm going to draw as big a box as I possibly can in this space to give us some decent profiling. Now because the noise is actually very subtle in this area under the table, it's pretty important to be pretty gentle with the settings here. So I'm going to actually dial the denoise amount back a bit. And once again, I'm going to switch to the final output, and let's zoom right in, and let's just disable the noise. And you can see that as I disable and re-enable it, it's just very slightly softening the blurry reflections and getting rid of that grain. And this is a great tool because it means that we don't have to get completely perfect renders out of Modo, because those last few percentage points of perfection are going to cost us a huge amount of render time. We'd have to increase the rays enormously to get completely clean, non-flickering, animated renders. But with these tools in Nuke, we can afford to have a tiny bit of grain in our renders and then fix them really easily. So what I'm going to do now is I'm going to do a frame cycle render from Nuke just so we can see how it looks in motion. And here is the Nuke render, and I'm going to hit play so we can see what it looks like once it's moving. And as you can see, there's definitely no flickering problems anymore in terms of grain. There's a little bit of icy flickering in this corner, but I'm really not too worried about it. If it was problematic, I could of course completely disable the second bounce, and instead of using 2 bounces of hybrid rendering, just use 1 bounce of pure Monte Carlo. However, I don't really want to do that for this shot because I think it's going to darken this this back wall too much, and I don't think it's really going to improve our render times particularly, but it's something I will test. And so just in order to do a quick test, I've switched back to Modo and I've dialed back my anti-aliasing samples and set the ray threshold back to 0.1%, and I've also set my frame size to half, and I've done a test render, and this is using the 2 bounces hybrid, and it's come in at 6 minutes and 32 seconds. So what I'm going to do is I'm going to go and set everything back to 1 bounce and disable the irradiance caching, and do another test render just to compare what that's going to do in terms of the overall lighting, and also to see what it's going to do to the render times. And here is the completed render, and it's rendered in just over 6 minutes as compared to the previous render with 2 bounces which took 6.5 minutes. So you can see that second bounce is actually extremely cheap in terms of render time. I mean, basically, even at full resolution, it'd only be adding an extra minute to our per frame render. And if I zoom in, you can see it does actually make a big difference. With the extra bounce, we get a lot more light on that back wall. And the other thing is that without the extra bounce, we lose some saturation, and also the actual Monte Carlo grain looks worse because it's darker and more desaturated. So personally, I think that that hybrid render is really worth doing, and it is very cheap, and it just adds a lot visually to the image. But of course, it does come with a caveat that any kind of irradiance caching is very hard to render in a stable fashion when you've got an animated scene. So if you do use hybrid rendering, you do have to look out for that flickering.